In this video, we will be discussing about this problem. The problem is saying that there is a 60 Hz sinusoidal voltage is there. So, frequency in the question is given as 60 Hz and the voltage, instantaneous value voltage is given as 141 sine of omega t. I will write in the phasor format. So, omega t minus 0 degree it is given. So, applied to a series RL circuit and the values of the resistance and inductance are 3 ohm and 0.0106 Henry. So, what is given? So, R is equals to 3 ohm and your inductance is equals to 0.106. So, what it is asking? Compute the RMS value of the current in the circuit and its phase angle with respect to the voltage. Okay. So, first we will find what is the value RMS value of the current. So, RMS value of the current is equals to Im divided by root 2. Now, how to find Im? Now, this will come from the expression I is equals to Im sine of omega t plus or minus phi, whatever we will get. So, how to get this? This is nothing but your whatever V is there divided by Z. So, that will give me the I. Now, let us see what is Z. So, Z is equals to R plus Jx. Okay, in this case only inductance is there, so it will be JXL. Now, R value is given 3 ohm, we know. What is the XL value? XL is equals to omega into L. Okay. So, omega is what? 2 pi f. So, frequency is given here 60. So, 2 into pi 3.14 into 60 into inductance. Inductance is given how much? 0.0106. So, if I calculate this value, so this will be 2 into 3.14 into 60 into 0.0106. Okay. So, this is 3.99 ohms. Now, my Z is how much? Z is equals to 3 plus 3.99 I. So, okay. So, now I have to divide this value with the voltage. So, voltage I will write this as, sorry, not here. So, my current, finally instantaneous current is equals to voltage is given 141 and here phase angle is given 0 degree. Okay, divided by, I have to represent this in the polar form as well. So, how to do that? So, to do that, so in calculator you can go to convert to polar, sorry, you need to convert to polar. X value is 3 and your y value is 3.99. So, converting that, this will be 4.99 with angle of 53.06 degrees. Okay. So, that will be here 4.99 at angle 53.06. So, this will be how much? If I calculate 141 divided by 4.99, so this is equals to 28.25 and angle is, so 0 minus 53, it will be minus of 53.06 degrees. You can calculate that as well. So, 141, so how to do that? 141 with an angle of it is 0 degree, okay, and then 4.99 with an angle of 53.06. okay. So, we will get this in this format and I can convert the answer to polar form and you will get 28.25 and angle is minus 53.06. So, like this you can do the calculation as well, just to show you. So, this is my current value. Okay. So, my current is equals to how much? 28.25, okay, sine of omega t, we got the angle as minus 53. So, minus 53.06. So, what does it signify? This signifies that current is lagging by 53 degrees from the voltage, okay, because it is a, see, inductance is there. So, because pure inductance, the lagging is 90 degree, because there is a resistance part is here. So, the lagging is because of the combination of that, and that comes as 53 degree. Next, write the expression for the instantaneous current in the circuit. So, this one is the expression for instantaneous current in the circuit. So, now if it asks any other questions based on this also, what is the Vrms, Irms, what is the resistance value is this much, what is the reactance value is this much. So like this all the things can be calculated here. So this much from this video. We will be discussing another problem in next video.